What we are going to do is scatter points on our curve. Let's just do it on our static curve for now. So not on the animated one, so it's just a little bit easier to see. So we get a whole bunch of points. You can see we get points. And maybe we want to turn off relax iterations. So relax iterations will sort of uniformly space them. So the higher I put this, the more uniform it will be. If I turn this off, they will be sort of more randomly spaced, which is more similar, I guess, to what it would be in real life. Maybe we don't want it to sort of start completely at the bottom. You kind of see that there's sort of, well, a ramp up. Like there's not really a lot here, but there's a lot there. They also get bigger the higher they get. So maybe we want some control for that. So let's maybe copy and paste the thing that we made here. So maybe call this thing movement. Let's copy and paste this thing, put it in there. And let's dive into that thing. And maybe, by the way, that's not copy and paste. Let's just make a new one. It's just if we do it again, it should be maybe easier to learn. So let's make an attribute file, put it on top, and dive in there. So we're not going to do any noise in this one. We're just going to bind our curve view, and then we're going to bind export another attribute. So maybe call this attribute density, because we're going to use this to say to say how dense should the scatter be, basically. So we just plug this in here. We get a second attribute called density, which will be the same as curve view. And then maybe put down a ramp parameter in the middle. And let's put it to, and of course we don't want it to be a color ramp, because you can see now we suddenly get like a vector density. We just want it to be a spline ramp. So let's go up a level, and now we have this ramp. And on the scatter, you see there's, so over here I'm putting how much should I, how many points should I put on there, but I can also put a density attribute. So I can turn that on. And if I let's say if I change my ramp, you can see it won't scatter on the bottom where the density is low, so the density attribute, but it will scatter where the density attribute is higher. And remember, this can be any attribute you want, because the attributes are arbitrary. If I call this attribute here, if I call it cheese, it will stop working. But if I then put it to cheese over here, you can see it works again. But let's just name it something that we can understand. Else your teammates might think you're crazy if you call everything cheese. I've been there, done that. So I tend to call a lot of stuff cheese. I even put tiny little cheeses in some projects that I've worked on. Anyway, so we have this sort of slider we can use to control how dense should the stuff be. So maybe put it something like this, so we have some control on that. And of course, remember to save regularly whenever you're doing this. I'm constantly pressing Ctrl S, but you should be doing the same. So anyway, we maybe kind of want to start copying some stuff to our points. So if we type copy to points, put something in, and then put down a line, because we want to copy a line, and put it like that. So they will all start copying to the top. Maybe like this. So if we type it like that, it will copy to the side. But maybe we sort of want to be able to give this a direction in which they should copy. So let's do that. So before we do the scatter, we want to maybe determine a direction. So let's put down a polyframe. Polyframe. So polyframe will make a normal and a tangent. So by default, this doesn't really do much, but let's put the normal to be the tangent. So, and now let's visualize our normal. You can see they will point upwards, but like, let's say if I put this on my moving thing, you can see they will sort of, the tangents will follow the direction of the curve. Let's plug this back in with the static one. We don't want them to follow completely the curve, we want them to sort of go like roughly in the direction of the curve, but then sort of move outwards. So let's make a attribute randomize. Let's plug it in there. Let's put this to, so right now it's doing color. Let's put this to n normal. All right, so instead of having them point like that, we kind of want them to sort of point randomly across this thing. So we can change these minimum and maximum values. So if a normal, so right now it's only pointing in a positive direction. So we kind of want them to also point towards the other side. So if we make this -1, and also make this -1, you can see right now they would be pointing in both the negative and the positive direction. And then we also have this control here to have sort of say, how much should they be pointing upwards? We don't want this to be negative, because if we were to make this negative, they would also be pointing downward. We don't really want that. But let's say if we put this into the movement and we're gonna play this. So they will be sort of facing upwards, but they are not really flowing with the movement of the curve. So perhaps that's not what we want, because we kind of liked the way this was behaving, right? So where they were sort of moving with the curve. So maybe we can try something else for that. So let's instead make a attribute VOP, and let's put it in here. And so after the polyframe, so the polyframe is going to go into the first input. So you see this thing has 4 inputs, and let's put the randomized into the second input, and let's dive in there. Let's highlight our normals. So first off, if we're looking at these normals, we can see they're pointing down, and maybe we want them to point up, right? Because we're looking at this thing kind of more of an upwards direction. They're going to go towards the sun, right? So kind of what we want to do is we want to invert these, else our copies would go down. So what we can do is we can put a multiply constant. Let's put it in the normal. And let's say we're going to multiply it by -1. So that will just invert it. So let's put that into the normal. Let's highlight that. You can see right now they're pointing in a different direction. So they're going from this to this. So that's already more what we're after. So then what we want to do is we want to import the normal from the second input. So let's type import, and you can see the whole menu appear. And you can say import point attribute, because that's what we're going to do, right? We want to import a point attribute. So where do we want to import it from? We want to import it from the second input, op input 2. Put it into file. You could also put it in here to be the second input, but just if we do it like this, it sort of visually makes more sense. So this would be the first input, and then would be the second input. So we don't really need to put in the point number for now, because the point number is just going to be the same. Because but sometimes you might want to do that. But in this case, we can just put n here, because what do we want to import? We want to import the normal. And now let's put, what do we want to do here? We want to mix these two together. So what will we do? We do type mix. Easy enough, right? Just type whatever you want to do, and something will probably pop up that will do whatever you want it to do. So in the first input, let's put our first normal, and then in the second input, let's put our second normal. And by the way, just to visualize, if we just put in the normal from here and just put this into normal, and we visualize this, you can see it will just be the normals from the second input instead of the first input. So like if we do this, you can see it's just gonna do that. But instead of just putting it to the second input like this, let's put this into the mix and then put this into the normal. And then you have a bias, which is say how much should I mix. So you can see we have a slider, so we can sort of mix between the two. Instead of doing it like that, let's promote this parameter. because so we have some control on the top level. And now you can see we can sort of do that. And then if we play, you see we have sort of a nice mix between our initial normals and our randomized normals. All right, so let's turn it to not go over the animated thing again. Just do it on the static one like that. And now if we go to our copy, you can see we have stuff going into the direction of our copies. And again, if we were to put this to the movement, you can see they're moving with the animated thing, but we don't want to do that for now. All right, so now we kind of want to control the size of these things. So we already have a control here for our for the density. So it will be this thing, maybe call this density. Because remember, we can just use this to control where they are scattering. And let's put down an attribute randomize, like that, and put it in here. Put it to 1, and it's type p-scale. So now you can see it's randomizing those values, and maybe we wanted to go from 0.5 to 1, and then have a global scale. So now you can see they're sort of randomized. The size is sort of randomized. And again, we're doing this inside an attribute randomize. We could also do this inside of an attribute VOP. If we just put random, put the point number into the random, you can see we get a float. We could bind export this to be called p-scale. And we could put a fit range in between. Promote the minimum and the maximum, because the input is always going to be between 0 and 1, so that's already correct. And then maybe we also want to do a overall multiplier. Promote the second input. Put that to, what did we put here? 0.43. 0.43, and we did from. All right, so let's look. So the randomization is looking a little bit different, but you can see we can just, so that's probably the randomization function under the hood is a little bit different, but it's essentially doing the same. This is doing the same as this, but right now we're building it ourselves. We can also do this in a wrangle. So I haven't really talked about wrangles yet. I am going to get into that a little bit later, but for example, in a wrangle, this would be, you could say that type float. So float would create an attribute inside a wrangle, which is not being exported out. Just call it R or something, and then say rand based on the point number. And then you could say R equals fit01, 0, 0.5 to 1. Oh, wait, sorry. R 0.5 to 1. And then times maybe our multiplier. And then at p-scale equals R. Again, don't worry about this facts thing. You don't really have to repeat this after me. I will get back to this in a later video on how this works, but you can see it's going to do roughly the same. So it's all looking a little bit different, but it's doing sort of the same thing. So just keep in mind, you can do the same in VOPs as in facts, and this is just probably faster to write than doing this thing. For just randomization, attribute randomize is probably the easiest pick, and there's 1001 ways to do anything. But for now, let's just remove these and just use the attribute randomize. Just so you know, you can also do this yourself. All right, so now we have this thing, and we could say that we kind of want to merge this in with what we already have, and let's put the copies on the movement, and then highlight our merge and play. So it's looking a little bit chaotic, but you can see we have a main branch and then having copies. moving with it. The copies don't really have any noise, so that's probably the thing we should probably do after this. And I can already tell you that this sort of chaotic movement will be problematic later, so we're going to solve that later, but one step at a time. Right, so let's just copy and paste our movement, FOP, and let's paste it over here. Let's have a look. Maybe reduce our copies so we have a little bit less to look at. And we kind of need more points on our line. So let's do the same as we did before. Let's make a resample. So we have some points on it. So maybe the smaller ones can have a little bit less points, maybe like 16 or something. And let's press play, and let's do this on the static one again. So it's just easier to look at just what this thing is doing. Always tackle one problem at a time, else you're going to be confused about what's happening. So let's play. So let's have a look. We need the resample. We have curve view. Let's have a look at this. Randomize, copy, movement. Okay, so this is not exactly looking like we want it to, because you can see the entire thing is sort of moving, which is probably not really what we want to. So why is it happening? Why is it moving similar to what this thing is doing here, but not these things individually? Let's have a look in our geometry spreadsheet. Let's investigate. So we have the curve view attribute, but let's look at our thing here. So this also has the curve view attribute, and it sort of looks like the same values as we have here. But shouldn't our values here be 0 to 1? So what's going on there? Well, because what this thing is doing is that the copy to points is sort of keeping the incoming curve view attribute and then applying it to all of our copies. And we don't really want that. We want this new curve view attribute to be on our copies. So you can see the copy here is saying like, what should I copy? So what it's doing, it's saying the star means it should copy everything, and then with the thing over here says except for, and then it doesn't copy any of these attributes here. So maybe we want to add something to that list. So let's just put so that's just the default. So let's put one of these and then type curve view. Right. And then let's have a look at what's gonna happen. You can see something already changed. So let's play. So that's already looking a lot better. So we probably want to go inside this movement. Maybe we want some control over this thing and promote this. We also need to do this on the other one because we hadn't really done that yet. Maybe we also want to promote the type. Maybe we want to increase the frequency, change the roughness. Maybe we want this to be a simplex noise. Maybe let's also do it on the other one. So promote these parameters that we have. Promote the frequency, promote the roughness, simplex noise. So this movement is already looking better, right? With the simplex noise instead of the alligator noise. You can see the alligator noise is a little bit sort of more rough. So with the simplex noise, it just looks a little bit more like we want. So I think in this one I also used the simplex noise. So let's type in there. So now this is looking a lot better. So essentially what this is doing, so every curve has a 0 to 1 attribute. So what we could do is, like, if we just select a curve, just press delete and then press delete non-selected. and then go to our geometry spreadsheet, you can see this curve has a 0 to 1. If I were to do this on another curve, let's say curve 1, you can see exactly the same. So then this whole movement thing will just happen the same on every curve. So let's have a look in our merged thing. So there is something going on there because, of course, while we're doing it sort of on the static thing. But if we go on our movement, maybe we want it to be a little bit more random, because right now they are sort of all being driven by the same noise that's moving through it. So maybe we want to sort of offset that a little bit. So let's do that. So let's dive into here. Let's think, how could we do that? So remember what we did before. We used a random function. So we put a random. And this random can take any input. So what could we plug in here to have it be randomized for every single one of those primitives? I'll give you a second to think about that. If you thought point number, you were wrong, because we don't want to do it for every point, because all of these, else it would be randomized for every single one of these points. And if we middle mouse on this, you can see we have a lot of points. We only have 20 primitives. So the 20 primitives is how many curves we have. So what we want to do is we want to use the primitive number. If I put this in there, it will generate a random value for every single one of these curves. So again, I could export this. And we want it to be a 1D integer, and we want it to be a, what do we want? We want to be a 3D vector output. And again, we could export this just to check it out. And you can see now we have a random value, but the random value will be the same for like a lot of the points, because those will belong to the same curve. But if they belong to another curve, the values will be different. So let's remove the export. And instead of doing that, let's just add this to our offset. So put an add, so like that. Let's put our add, our random into the add, and let's watch what happens to the things. Let's plug it in, and you can see it changed. So and now you can see we get a much more random sort of look. So if I turn this off, you can see it's very uniform. You can see right now it's a lot more random. So we could add more randomness to this if we wanted to. So what would we want to do? So something we hadn't really discussed yet is, so we put the time into the offset, right? So what we hadn't really done yet is that we could put a multiplier in between the time. We also need to do this, by the way, later on the upper level thing. Let's promote this and then call this speed. Speed, right? So right now, if I play, nothing will happen because this time now is being multiplied by 0. If I increase this, you can see it will be very slow. And if I increase it like a lot, you can see it will be very fast. We also need to, let's do this also on our movement here. So we have our time. Let's multiply, promote parameter, call it speed, and speed. So we have some control over how fast it's going to be. So something like that. All right. So we have our speed, but maybe on this one, we kind of want the speed also to be sort of randomized for every single one of our copies. Why is it not working anymore? Let's remove this, promote it again. So what we can do is we can go in here. Maybe let's call another random function. And again, based on the primitive number, but now we want it to maybe be a 1D output, so a float. And let's fit this. Okay, so if we, let's first just multiply the time also by this function, see what happens. So you can see some will be super slow and some will be quite fast. If I make this the speed, if I bump up the speed, it will be more extreme. You can better see what's going on. Some are super fast and some are very slow. We probably don't want it to be like that extreme. So we could say fit range. So again, we're just gonna, so this will be 0 to 1 value. Again, you could check this by bind exporting this. So let's say we want the destination min to be 0.7 and destination max 1. So just a little bit of randomness. Let's play. So now it will be quite a bit more random. Let's merge this in, and you can see this is still not really what we want, because of course this is right now this is animating like that, so that's probably not really what we want. But we also had this problem where if we plug this in, and this is way too fast, you can see. Wait, let me slow this down. You see they're sort of weirdly jumping around. So what we actually don't want to do is we actually don't want to animate this thing, then copy to it, and then do the then copy to it and then merge it all back together. What we kind of want to do is maybe drive the main movement after we done all the copies, but still animate the individual copies themselves. So what we then would just do is just remove the animation there. So right now it's just, this would just look like this. And then we just want to add the movement over here. So now, and there's still something going on there. So why is that? Let's have a look. And we're doing it by the curve view. So that's probably not right now the best way to do it, because now right now it will, this whole thing will sort of be randomly offset by the curve view. So we want to think of something else what we could use to sort of, so we want to think of something else that we could use for this offset. So let me think about that for a second. We could maybe just use the height of this thing. So that might be a thing, right? So let's just do that. So I want you to think a little bit about how you could use the height for that. Maybe try it for yourself before I show you. Because of course, if you're gonna come up with the solution yourself, you're gonna learn more, but I'll give you a couple of seconds to pause the video. And you didn't pause the video. So let's show how you could do that. So we don't want to use the curve view. What we want to do is we want to use the y position, so the height. But that's a vector. So what we want to do is say vector to float. We want to split this vector, put it in there, and then we get the y component, and let's use that as a multiplier instead of our curve view. So let's remove this. Let's remove this. Right, so this right now, so you can see that's working, but it's a little bit extreme. So maybe we want to fit this value. Let's put a fit range. And we want to maybe promote the source max. So let's put the maximum. So that's going to be the height of our, so the source max will basically be like what will be the cap which will influence this thing. So if we, so let's open this a little bit and put it like that. So that's already looking better. So maybe we want to drive the maximum value by the length of our line. So let's copy parameter. And let's paste that into relative references. So now this will, the maximum value will be just the length of our line. So that's looking quite nice. Actually, I think looking better than the one that I had in the demo. So now we have this nice moving line. And now we have, of course, we have a scatter, so we can increase the scatter. I think maybe the speed is a little bit too extreme, so we can just tone down everything. And we can, like we have the density thing, right? So we have that. So something we maybe want to do still is that the scale here starts off small and then gets bigger, which we don't really have right now because it's just as big everywhere. So how could we do that? Okay, so what we have here is we randomizing the p-scale, right? So let's say we have so we already have an attribute that we can sort of use for this. So maybe let's try this in a, let's do it in a VOP. So let's go in there because we already have a couple of attributes we can use. We have curve U. So we could use curve U perhaps. So let's have a look at that. So what we maybe want to do, let's maybe do this, looking a little bit around. Did I maybe, yeah, so what we're doing here is we are putting a binding curve U, binding it to density. Maybe what we also want to do is bind export over here and bind this to p-scale. Oh, no, not p-scale, p-scale. Right, so now we have a p-scale attribute. So now on our point, we will also have a p-scale attribute. And then on the attribute randomize, we'll just override it. We don't want to override it. We want to maybe multiply the existing value. So have a look what that looks like. So now you can see they start off super small and then they get bigger the higher they get. And again, you could add a ramp in between to sort of randomize that. And with the density, I probably maybe just want it to be like that. Just want to start lower. Now look into the movement. Maybe up the frequency, turn down the amplitude. So I think that looks kind of cool. So now the main thing that's left is sort of generating a mesh for this thing. So you could also have these curves be rendered at render time, but for now let's generate a mesh for it so we have something to look at. We could also do that at render time, but let's just do it with a sweep.